Okay, just like we have seen high frequency response in common base, let's look at low frequency response in common base, and specifically let's look at how to calculate FL. So this was our circuit: CB, R2, R1, RC, capacitor C2, C1, RS, RE, VI, V0, RL. Okay, so its low frequency response will be corresponding to this CB. So we have three capacitors, external capacitors. So we will have three values of FL. Okay, for C1, for C2, and for CB. First we will calculate for CB. So FL1. Okay, corresponding to CB. This is how the circuit will look like. VI is shorted, RS is there, capacitor is shorted, C1, C2 is shorted, RC is parallel with RL, then RB is R1 parallel R2. Okay, this CB is as it is, and this is the model: beta IB, beta RE, and RS RE. Okay, so you can see, if you will look RTH1 from this side, from capacitor, this RB will be in parallel with this combination. Here RE and RS are parallel, you can see. Okay, and here the current is IB, but here the current is 1 plus beta IB, so I have multiplied 1 plus beta. Okay, so RB in parallel with the sum of these two, okay, sum of these two, beta RE having current IB, and 1 plus beta RE parallel RS having current IB. That's the reason I have multiplied 1 plus beta. We have seen this before. Okay, because we wanted same current in this branch, so I have multiplied 1. I took 1 plus beta with RE parallel RS, so that the current across this will become IB, and this guy will become series with this guy beta RE. Okay, so this will be the equivalent in parallel with RB. So that is RTH1. So FL1 will be 1 by 2 pi RTH1 into CB. Okay, so this will be FL1. Now FL2 and FL3 likewise we will calculate. Okay. Okay, now let's look at FL2. FL2 is corresponding to C1. Okay, so this guy and this guy will be short. So here CB is short, C1 is active, and C2 is short. So because RB will be short with this parallel guy, okay, so RB will be short, so it will be replaced by a simple short branch, then IB, then beta RE. From here we have to look for resistance RS, ground, beta IB, RL parallel RC. Okay, everything is same. So now if you will see, the current in this branch is 1 plus beta IB, the current is in this branch is beta RE. So beta RE divided by 1 plus beta I did, so that these two guys will become in parallel. Okay, this between this point and ground, in this point and ground. Okay, so they both will become parallel. RE parallel beta RE divided by 1 plus beta, and they are in series with RS. So that will be RTH2. If you plug RTH2 C1 value, you'll get FL2. Okay, now remaining is C2 FL. Okay, so FL3 will calculate. Okay, so let's look at the third guy, FL3. So with respect to C2 we are looking at, so this will be the circuit. CB is short, C1 is short, RB, IB, beta RE, beta IB, RE, RS, C2, RC parallel RL. So this guy will be short with this guy, so you can see IB, beta RE, beta IB. From here we have to look for equivalent resistance, RC parallel RL, RE parallel RS. If you will see, these two are in, can be in parallel if I divide this resistance by 1 plus beta. Okay, first thing. Then second thing is, if you will apply KVL in the first loop, input loop, you will have beta RE IB plus 1 plus beta IB into RE parallel RS. The drop across this plus the drop across this equal to 0. From here you will get IB is equal to 0. Means this guy will be open. IB equal to 0. This is a current source, so it will be open. Okay, it is open, and it is in series with these two parallel combination. So overall it will be open. Okay, so this is how I can imagine. So this is a resistance connected in parallel, beta RE divided by 1 plus beta. Okay, now these two are parallel and in series with this, but this guy is open because we can see IB is 0, open in series with some parallel resistance. will be open. Open means R is equal to infinite. Infinite plus this guy will result in infinite. So RTH3 will be infinite and FL3 will be 0. Okay, 0 hertz. So that you can see. So sometimes it happens. It depends upon the arrangement. Okay, so this will be the RTH3. Now you have all the FLs. So you calculate the maximum value of FL. So FL will be equal to max of FL1, FL2, FL3. Okay, and this is 0 hertz. So out of these two, you have to pick the maximum one. Once you will calculate the FL value, you will once you will calculate the value of FLs, FL1, FL2, FL3, pick the maximum one, that will be FL. Now you have your frequency response. A midband mod of A mid divided by under root 1 plus FL divided by F square. Okay, so FL is known here. For any frequency you can calculate. Okay, A mid is if you remember RE dash divided by RS plus RE dash GM RC parallel RL. Okay, so this is how you will calculate the low frequency response for common base. Okay.